All right, so let's start with the first one. Which of the sides is opposite to the angle x? So in right triangles, we have three sides. As already know, it is clear. Three sides. The side opposite to 90, degrees, that side is called hypotenuse. Let me use this HYP for hypotenuse, okay? So we have two sides left. So the side AB and the side BC. So we are dealing with the angle X. That means the BC, which is opposite to the angle X, BC, will be the opposite side. I'm going to use OPP for opposite, okay? I think this is clear. The angle X, opposite side will be the opposite side for this angle, okay? So hypotenuse is AC, opposite is BC. So we are left with only one side, which is called adjacent, okay? Which is called adjacent. All right, so actually let me write here ADJ for adjacent and opposite. So which of the side is opposite to the angle X? So the answer will be BC. Which of the sides is adjacent to the angle X? The answer will be AB. All right, so next one, we have to find sine of the angle A. We have, you see here, we have angle A. So what was sine? We are using the SOHCAHTOA. What is this SOHCAHTOA? It is an easy way to remember the sine, cosine, and tangent formulae. All right, so what is sine? Sine is equal to, sine of any angle is equal to opposite over hypotenuse. So opposite over hypotenuse. All right, so let's look at this triangle. Which side is opposite to angle A? 12. 12 is opposite to angle A. And what is the hypotenuse in this triangle? The hypotenuse is always the side opposite to 90 degrees. So it is 30. Hypotenuse is equal to 30. The sine of A, the side opposite to the angle A, which is 12, and the side opposite to the 90 degrees, which is hypotenuse. Opposite over hypotenuse is sine of A. Okay, so this is 12 over 13. All right, next one. We have a right triangle, as you see. Cosine of T is the question. What is cosine? So let's remember SOHCAHTOA. So the cosine is adjacent over hypotenuse. So the cosine is adjacent, but adjacent to the T, adjacent to the angle T over hypotenuse. Hypotenuse is always the side opposite to 90 degrees. All right, so we are dealing with the angle T, so this is opposite, right? This is opposite. There was some sound, so I have to mute them. All right. So this is always hypotenuse. Hypotenuse, let me put it in brackets, because the side opposite to 90 is always hypotenuse. And what is left? 2 is left. It is adjacent to the angle T. So the answer is going to be adjacent is 2 over hypotenuse. We don't know the length of hypotenuse. So let's say that it is C. We are going to use the Pythagoras theorem. So it's going to be 2 squared plus 3 squared is equal to C squared. So 2 squared is 4. 3 squared is 9. C squared. 13 is equal to C squared. So C is equal to positive root 13. C may be also negative root 13, but the length cannot be negative. So C is equal to root 13. Right, cosine of T is equal to 2 over root 13. So actually we can, this is the correct answer. We can rationalize the denominator. So 2 over root 13 times root 13 over root 13, which is 2 times root 13 over 13 is also cosine of T. So it was the last question. This is the last one. In this triangle, in this right triangle, we are going to find sine of alpha over cosine of alpha. So we are dealing with the angle alpha. Let's find the opposite angle, opposite side to the alpha, or the adjacent side to the alpha, and the hypotenuse. All right. So let's say that the length of this side is x. We have to find x first. So Pythagoras theorem, x squared plus 1 squared is equal to root 10 squared. Okay. So the Pythagoras theorem, the side opposite to 90 degrees to the power of 2 is equal to, which is hypotenuse squared, is equal to 1 of the legs squared plus the second square of the second leg. Okay, the sum of the squares of the legs. All right, so x squared plus 1 squared is 1. Root 10 squared is root 10 times root 10, which is 10. Root 10 times root 10 is equal to 10. So x squared is equal to, you can take plus 1 to the right, it will be minus 1. 10 minus 1. X squared is equal to 9. X is equal to 3. So now we can erase this x and write 3 here. Let's find sine of alpha. Sine of alpha is opposite over hypotenuse. So SOHCAHTOA, let's remember SOHCAHTOA. SOHCAHTOA. Sine is opposite over hypotenuse. Which side is opposite to alpha? 3 is opposite to alpha. And this is always hypotenuse. The side opposite to 90 is always hypotenuse. So the other side must be, the last one must be adjacent. So sine of alpha is opposite over hypotenuse, right? So 3 over root 10. 3 over root 10. Cosine of alpha is equal to adjacent over hypotenuse. You see? Adjacent over hypotenuse. So that's going to be 1 over root 10. So the question is sine of alpha over cosine of alpha. Sine of alpha over cosine of alpha is equal to, sine of alpha was 3 over root 10. 3 over root 10. Cosine of alpha was 1 over root 10. 1 over root 10. So we write the first fraction, 3 over root 10. times, we take the reciprocal of the second fraction, root 10 over 1. Here root 10 and root 10 cancels out. All right, so the answer is going to be, so the answer is going to be 3 over 1, which is 3. So this is sine of alpha over cosine of alpha. So did you realize something? So let me explain that. All right, so what was sine of alpha? Let me write sine of alpha over cosine of alpha. Sine of alpha is opposite over hypotenuse. Cosine of alpha is adjacent over hypotenuse. So the first fraction will be written opposite over hypotenuse times, we are going to take the reciprocal of the second one, hypotenuse over adjacent. So the hypotenuse and hypotenuse will be canceled out. So we are left with opposite over adjacent. What is opposite over adjacent? Tangent is opposite over adjacent. Tangent is opposite over adjacent. So we can say this is tangent of alpha. You can check actually what is tangent of alpha. TOA, tangent of alpha, opposite 3. Opposite over adjacent, adjacent 1, 3 over 1, 3. So that means as a property, we can write sine of any angle, for example, sine of x over cosine of the same angle, cosine of x is always equal to tangent of x. All right, this is all for today. Thank you very much for listening.